Hello and welcome everyone. It's a pleasure to be here. It's my first QCon ever, so I'm very excited, just moderately stressed, which you can read between the lines, very, very stressed, but it's a pleasure to see you. My name is Andrzej Grzesik, but it's very hard to spell, it's very hard to say if you don't know how to say it, so I go by Axe, so feel free to call me Axe. I'm an engineer at Revolut, which means I write code on a daily basis, and I get frustrated when things don't work, but usually they work, or that's what I'm trying to make it do. A few facts about me. I'm very proud to be a Java champion, very, very proud to be old enough to have gone to Java 1 in time to become a Java 1 rockstar. I also happen to run Polish Java user group, a conference called GeekOn, 2 meetups. Geographically, I'm from Poland, we're in London, but you know that all. My opinions are my own, which means any mistakes that I make are mine and mine alone. All the good things are, well, I'm very happy if you benefit from them. If you have questions about the talk, raise your hands. There is a microphone that can probably float towards you. If you have them in the middle of the talk, just wave, because the question might escape you, or take a note. I know that we have an AMA with me, Ben, and Emily towards the end of the day, in the schedule at 4:10, I think. So if any questions come to you later in the day, there will be still time to talk to me. If you would like to talk about Revolut and working there, definitely not during the talk. Let's focus on Java 11 and how that works in production. All the other things in the breaks, over lunch, later in the day. So I like to use pictures that make me laugh because it's a reminder that I should be drinking more water, of course. And yes, Ben kind of beat me to it already by asking which version of Java are people on, and I was going to ask you which versions of Java you're on, but since this question already has been asked, most of you are on the LTSS editions. Congrats to the brave people who are on the more modern versions, but we are looking at doing something similar later. Which version of Java are you on? I think we don't have to repeat the exercise. That's obvious. What we are going to talk about is how we went from Java upgrade in the context of a particular company, because the context is always very important. What you probably know about Revolut is that a financial company, we have a product that's a credit card or a card and an accompanying mobile application, but the important facts from a software engineer's point of view is that the company is 4 years and a bit old. It has over 10 million users, which means it's growing like crazy, and the usage on the systems is growing like crazy. The number of developers keeps on increasing. So all the problems that we can avoid having, if there is anything that gives us that, we're very happy, because this allows people to focus not on production issues, but instead of building and improving the code base and building out new features and scaling globally and expanding the reach. That's for us very important. We obviously, in the code base is very opinionated, and the code base is opinionated in a way in which, for example, we don't use Spring. Some people might have heard about it. Why? Because debugging annotation-driven problems is not fun. Ben already mentioned that as people spend more and more time with computers, they prefer less creative solutions to some problems. I even describe my job that I keep doing the same year in, year out, and I put boredom in places. I don't want certain things to be exciting. It might be counterintuitive, but there is a lot of fun in building stuff in general, but I don't want surprises. And especially if I've had an amazing evening somewhere, I don't want to receive a phone call and then I have to look at squiggly lines and I have no idea what happens. If you've read some very esoteric looking languages, or if you've seen somebody who was trying to do a very smart version of Scala or Haskell code, I find Java much more readable in places. And this is the attitude that we have in Revolut's code base everywhere. So we prefer to use code-driven everything, not annotation-driven. We prefer to have compile time checks rather than runtime explosions. Yeah. Also, we don't, sadly, or not sadly, have 1,500 microservices. We have what I would call services, much less of them. It's more controlled. In terms of deployment, what does deployment for a typical application look like? We have CoreOS, which is coming to an end of life, so that will be a fun bit. We run applications in Docker. There is one application in a container, which means that we don't share the instances between things. There is fluentd, which represents also all the other daemons that would sit on any of the instances. We use a framework called Java Spark. Why? Because it's extremely simple and very easy to debug, very easy to reason about, and if something goes wrong, that means you don't have to worry too much, because it's all in there. We also use Juke, I think that's how you say it, which is a database interaction layer. We don't use Hibernate because that gives us more control. And people that I work with like to have this explicit control. Of course, that means that sometimes you have to write a bit more. But if you want to write, build distributed systems, at least from my experience, being afraid of SQL or whatever the actual language of the platform that you're running with is, well, you'll have to get over your fear. And the question is then, why should we upgrade? If we're moving fast, if we stay to Java 8, we're probably, well, it might be a nuisance, it might be useless. Well, some corporate entities choose not to upgrade. Some corporate entities, as has been already demonstrated, are still before Java 8. That's, of course, their choice. But then comes the aspect of culture. The aspect of culture that is visible by those letters that are shining. People in a startup have a mentality of building things so that they can get shipped. Which means if there is something that can allow you to go faster, you probably want to do it. We are trying to move fast because we have to move fast, otherwise, well, the product will not happen. We cannot obviously break anything because it's a financial company and we are put under a lot of scrutiny, because if you're dealing with people's money, it would be very bad if we lost any of that. So there is a lot of auditing and there is a lot of processes that we have to follow because we're dealing with money. That's obvious. If something needs to be updated, if it's on the core path, because people see it, people are eager to make those changes because they remove friction. So why upgrade? Well, because to get it done. Also so that we can move fast, because as I already mentioned, Java 11 is, or hinted, Java 11 allows us to move faster without worrying, or with worrying less. We also would have to upgrade anyway. It's a fact of life that software gets, well, towards the end of the life cycle, new exciting features like everything that Ben described, hopefully is coming in newer Java versions. This is something that everybody would like to benefit from. There are changes in JDK 11 that we have benefited from, and I'll talk about them later. But if those features are out there and you're on the previous JDK, it's a bit hard to use them. So, well, we want to upgrade. And there is this guy. This guy represents the almighty JSON. If you're dealing with applications that talk JSON to themselves, which most of us do, probably, there is one feature that happened between Java 8 and Java 9 that we also really wanted to benefit from, which is Java length string does not have a char array internally, but they have a byte array, which means, yes, you do get half the size of the maximum length of a string that you can store. But the more important part is you are storing bytes, which means it's half the size, which means you are, if your strings are ASCII, basically, you will use half the memory, which is an extremely important feature. It's a very nice feature, and if you're doing JSON manipulation, which many of us are, because, well, this is how the web communicates, because the internet still runs mostly in debug mode, plain text, and so on, we benefited from this. If you need to do something more with strings, you can, well, string deduplication with G1, even in JDK 8 might save you, but string deduplication at some, there is a price to pay, and this change you get for free just by switching from 8 to a newer JDK. So, well, you can admire my mad Photoshop skills here. JSON is now happy because obviously it takes less time and less memory. And now, the follow-up question is, we're a financial company, so how could we do it? What groups did we have to reach out to? How did it actually happen? Well, we do a lot of automation. A lot of automation in our context means a lot of YAML files. Yes, I know there are very strong fans of YAML files everywhere, here inclusive. But we automate a lot, so we have the infrastructure, the images, how applications get built, that is expressed in code, which means anybody who is capable in using a text editor can change that and can influence the process. Also, we are trying to, well, keep this startup mentality in which we want to push and build things as quickly and as well with as little friction as possible, which means developers take care of many infrastructure tasks, which also means if you build a piece of software, well, you get to maintain it. But if you get to maintain it, you should probably have a say in what environment it's running on, because if, for example, your software, the usage for your software has outgrown the resources that have been dedicated, and you know that you need to upgrade, why should you require a separate team to do something about it if you can do it yourself? If you have this self-service culture built into how infrastructure and many of the places, of course, where it's applicable, because I mentioned fintech and there are some limitations which don't allow us to do absolutely everything that we wanted. But if it's possible, we want to automate it and we want to empower people that are people closest to the problem. There is a PR that will get a code review. Team City will hopefully run a build that will update whatever needs to be updated. And yeah, that's how things end up in production. That's automated, and that happens almost by itself. People don't need to do it all the way manually. Which also would probably raise the question further, do we have any ops people? Of course we do, but they work on more specialized tasks that developers, people who write Java code on a daily basis would probably take a bit more time to learn and figure out how to do correctly. That's all. So what did we do? We upgraded to Java 11 from JDK 8, update 2.12, and that particular build, not super important. And we did it to all the apps. So all applications within Revolut doing Java and the backends run JDK 11 now. Of course, the team that runs Android, I have no idea what they do because I don't deal with Android. There might be some limitations there. And why 11? Well, because 9 and 10 were no longer maintained. I assume you know about the release cycle. If not, we can talk about it after the talk. I don't want to show the same graph that everybody has seen already so many times and discussed more than a few seconds. And 12, why 12? Well, 12 wasn't available when we got to it. And the subject of, well, the title of the talk is A Year in Production with JDK 11. This, in case of Revolut, means Revolut has been running JDK 11 in production for over a year now. And we are quite happy with what we have seen. It wasn't a journey without some hurdles. There were some thorns on the way as well. And some mandatory slides, why not Oracle JDK? So we went away from Oracle JDK. We are using Docker, so we bake images. And with Oracle JDK, there is a license that is very complicated, and lawyers like to read that language. I find it tiresome. English is not my first language. Lawyer English is like a special version of English. How I understand this license is I cannot build my own images. I cannot give people a copy of the Oracle JDK. People should download it from Oracle always because Oracle should be the distributor. I can't. And it also requires a license to run in production. And getting a license from Oracle, I don't know what the process is for 11, but we decided if there is an alternative, we can use an alternative. We probably will use an alternative. And is there anybody who is unfamiliar with JDK release cadence? Don't be shy. We can talk about it after the talk. Those are the slides that we will use when talking about it, but after, not now. So, if you want to go Java 11, you have two choices. You have a choice of, let's do everything 11. We can compile on 11. We can run on 11. If you can, it's awesome, absolutely. You can also choose to compile on 8 and run on 11. This is what I used to do before I joined Revolut, to some very good results, because there are new features, there are new fixes to the runtime happening continuously. So we are using this version. Java 11 is everywhere. It's what it gets compiled with. This is what it runs on. People don't use JDK 8, I don't think anywhere, or mostly anywhere. But also, if you are not in that situation, it might be that you will have to use Java 11 without a full Java 11 toolchain. When would that be? Well, if you have dependencies, and there are some dependencies which are very nice, very useful, but you might not have upgraded. The version numbers I'm using are from the project's respective websites. I didn't verify whether the numbers are actually correct. I used their information, so all the mistakes, this is probably my copy-pasting went wrong. But if you are running, for example, older Cassandra, older Grails, especially older Hadoop, planning an upgrade to a version that actually supports 11 might take time. And it might be that you will be forced for some time to compile with 8. Especially if you have a dependency that uses older version of Thrift somewhere. It can be finicky, it can be very particular about the JDK version that you run it on, and that's the fact of life. Then what you get to do is compile that piece of code with 8. And until you manage to upgrade whatever your environment is on the version numbers, then well, you're kind of stuck. And this is also possible. This happened to me before. We were having a lot of Spark-related code, so we would compile on 8, and then we would run on 11. A bit convoluted, a bit funny. Some unusual situations might happen just purely because you switch from 8 to 9, which starts to do modules and then removes a bunch of things. But it is also an option. It's absolutely a viable option. It's absolutely okay. It's socially and morally acceptable to compile on 8 and run on 11. Build tools. If you choose to do so, there are two tools called JDEPS and JDEPRScan. JDEPS shows module dependencies. It has this amazing command line, especially the -- class path thing is great for any enterprise project. If you can imagine typing all the jars that you would have to type in there, well, I couldn't and nobody else can. So there is a Gradle plugin, there is a Maven plugin. You can put that as part of your build. There's also JDEPRScan. Probably that's how you say it. It also has a class path option, and it also comes with a Gradle and a Maven plugin. And the hidden fact of life is you also get the features that these two good people deliver by using Java-C. So we didn't use those. I mentioned them for the sake of completeness. If you need to go through that process, the tools are under the bin directory of your JDK, but you don't have to. If you're using Maven, what you will have to do for sure is upgrade compiler plugin to 3.8.0, which is kind of dated now. I think you can go up a few versions on top of that, but this will allow you to run with more modern JDKs. But also, since I mentioned Maven, Maven users in the room probably might have seen Maven Versions plugin. Maven Versions plugin has this awesome feature which is called Display Plugin Updates, which can tell you which plugins that you have within your Mavenized view of the world can be upgraded and what requirements do they come with. Obviously, the list that this plugin produced has been much longer, and we're on the 5th floor, so I would probably end up with somewhere underground because it was a really long list. But if you require Maven 2.02, you can upgrade Maven Java.plugin from 2.10 to 2.2. Does it really make sense? Discussable, but it will tell you a lot of things that you can actually upgrade. I think it has an option in which it can actually upgrade to whatever it thinks is the correct choice. But I don't trust Maven that much. I prefer to change versions manually and verify that things work, but at least it can give you an automated report about what's possible, what can happen. Another awesome thing that Maven can do and can help your pains when upgrading software or following what software updates are out there already is versions display dependency updates. So as for plugins, it can do the same for your dependencies, which is very, very useful. Gradle, if you're using Gradle, like for example we are, if you want to run Java 11, V5 is good, V6 is good. If you're on V4, my recommendation would be go to V5 first, go to V6 second, because if you try to upgrade bravely from V4 to V6, I will probably wait for you to say that you actually decided to go with 5 in between because it's just easier. V4 to V6 is a bit of a rocky ride. Directly, do it with the interim step. People have tried, well, I think it's a popular opinion that putting a V5 in between is a good step, but you can stay on V5 and you don't have to go V6 immediately. And now we'll go through some libraries just to show you what's happened. So For example, Mockito, an amazing library originating, well, back to an office I used to work with, so that's a very personal story because we worked with the authors in the same company at the time. But formally, it supports JDK 11 since 2.20.1. If you looked at release notes in the doc directory of Mockito, you will see releases that tag some sort of JDK support, bug fixes or changes with a few numbers. If you look at JDK 9, you will see also official support happens, and then there is some other bug fixes that happen. What I'm trying to say between the lines here is the official support does not sometimes sadly equal that everything will work as expected, because those JDKs change reflection, they change bytecode generation quite significantly. So if you have libraries that do that within your environments, you might get unexpected surprises. Sadly, or it's a part of life. It happens to Mockito, it happens to all the other libraries as well. Also, it might be that because we've done it a year ago, if you take the latest versions, you will not have to go and discover all the fun problems that people have solved, because the world keeps moving forward and people upgrade the libraries, and now most things seem to work on 11 reasonably well, with the exception of modules, because modules are not fully supported by some languages, but we'll get there. We also use Juke. Juke officially supports JDK 11 since 3.12.0. We actually are still on 3.11 something. We probably should have upgraded, but it turns out we didn't have to because it still works. Flyway. If you do your database migrations manually, this is my personal, advertising banner for the authors of Flyway framework. It is something that helps you manage database migrations. Super nice, super easy, runs really great, gives you repeatable, testable databases. And if you combine it with test containers, you can run database tests and all the other tests within a container in a repeatable environment. We use Postgres, so that works out of the box. If you have to use Oracle database, I have no idea what the case is there, but as I said, this is a talk from our context. Flyway supports JDK 11 since 5.2.0. We actually encountered some issues when we tried to upgrade Flyway, and we decided to stick back to 4.2.0, and we are still there because it works for us without any problems whatsoever. And somebody once joked that if you want to come across as an expert in the Java land, you should mention JEPs by numbers. I am not in that space. I had to Google it. JEP 3.2.0 is the one that removes some components of Java EE from the from the JDK. So there has been JAXB that was part of your JDK in 8. It's no longer there. So if you want to use JAXB, or if you want to generate some code based on WSDLs, you will have to explicitly add those tools to your builds. That's all. That's all this JEP does. That's all the modification that this JEP forces potentially on your applications. Languages. Which languages do we use? I already said we primarily use Java everywhere. We default to Java. We're quite happy with that. But we also use Groovy in places. Why Groovy? Because it has Spock. Spock is awesome for writing tests. That's my personal opinion. We have upgraded Groovy to a version that supports JDK 11, and this just worked. Not much time to spend here. Kotlin, we also use Kotlin in some places. If you ask me personally, I personally prefer Scala, but there is a lot of people and a lot of opinions, and I will not tell people what to do because, everybody has their own, and that's fine. And Kotlin supports JDK 9 to 12 since 1.3.30. And again, this just worked. Awesome. Scala, we're 2.12.7. We just switched versions of the underlying JDK, and it just worked. Awesome. If all features, all changes happened like that, life would be beautiful. And the small notes. JDK 11 compatibility or support in terms of Scala is not fully complete because it doesn't fully follow the Java platform module system, and you will see this is a very popular thing that's not fully out there yet. So if you want to heavily rely on modules in Java and tie it with the language support, that might not be there. We are not doing that because our applications are isolated and they sit in their own containers. We don't need it. But if this is a killer feature that you would like to see from, for example, Scala, check the current state because they are still working on it, or the last time I checked, they were still working on it. And I mentioned Postgres, and I mentioned testing with Postgres. So historically, a year ago, we used to use something called PostgreSQL Embedded. And PostgreSQL Embedded was a very nice project with the tiny caveat of A, it stopped being actively maintained, and then somebody after that, after they stopped maintaining it, upgraded it to make Java 9 Plus compatible. But because both of those commits in the red frames happened before, well, they happened after we migrated, we actually switched to test containers and we never looked back. Also, because this project is not really developed anymore and test containers we are very happy with, my recommendation is use test containers. If you've never tried it, if you have to mock a database, bring up a database for integration testing, absolutely do it. It's an awesome tool, and the authors of frameworks are also frequent visitors to many conferences. They are very approachable on Twitter and other mediums. Wholeheartedly recommend. Dependencies. So let's say you want to tackle the problem of upgrading. Sorry, no corona here. And you have three components, component A, B, and C. A depends on B, B depends on C. And well, in the case of what I deal with on a daily basis, there is the application that actually delivers the service that depends on an Alpha framework. Alpha is our own event sourcing CQRS framework, and Commons is, as you guessed, is a Commons library. Everybody needs one, everybody has one. So what we started doing, how the migration actually worked, is we took the outermost layer, first making it compile without any problems on Java 11. That required some library changes, that required some build file changes, that required some Gradle file modifications. This took some time, wasn't particularly painful, and after that we started testing using 11. Then we started running this using 11. Previous components were being compiled and everything was there happening with JDK 8. After we did with the outermost layer, we went one level deeper, and so on and so on. You get the pattern. And now I should mention some of the funny quirks that we encountered on the journey. For example, Bouncy Castle. In JDK 8, I know a lot of people that used to install this into the JRE libxt directory. This directory is no longer present. If you want to install it to the same effect in JDK 9 Plus, you have to do this thing. Also, at the bottom of the slide, there is a link. You don't have to try to write it down. What we do with Bouncy Castle now is add it to the dependencies normally, and it just works, and we're happy. No problem, no magic required. Awesome. There is also the case of VM options. You are at QCon, which means you are amazing. You probably heard about unified GC logging, the syntax of getting output from GC logs changed, and the format changed as well. What this means in practice, we replaced top with the bottom. More or less, of course, and bonus points if somebody spots something funny at the bottom while I drink. I see some people notice the Jar Jar roaming. Yes, what happens is the line that tells the JVM to log everything from GC becomes simpler. That's it, all change that there is. If you have very big command lines, if you think it might be a problem in your environment, somebody was very kind and developed this tool called Jacko line, which can tell you what's good in JDK 8, and then if you switch to JDK 11, it can tell you what's no longer good. Super awesome, super neat. We didn't have to use it. I found it much later, but it's only fair I mention it. Also, whenever I mention anything to do with command lines, I always like to say huge thanks to Chris Who Codes, who is the person behind this awesome website that takes all of the flags that different versions of JDKs contain, and it gives you a human readable description. It tells you what the default is, which component, which architecture, which operating system is that specific to, when has it appeared, when it has disappeared. So if you want to explore that area, Chris who codes, and there is a link somewhere on the slides. Another fact of life that we have discovered is Java 9 came with a new zip file implementation, which means one flag we could kill, minus the sans zip disable memory mapping, it's gone. And it's gone. If you've seen South Park, it's gone. Time precision, a bit of a problem, or a bit of a source of interesting things and phenomenons. JDK 9 has increased the precision of the Java time clock depending on the precision of the underlying operating system source. That seems like a very innocuous change. But in reality, it's a very profound one, because what it means, if your operating system can be more precise than milliseconds, it can give you actually microseconds in that clock. What that means in turn is, well, of course, I mentioned depending on the operating system. I don't know what the level of support is on Windows. On Linux, it works and it's more precise. That's what I can tell you. Windows I don't use, so I just don't know. Since I'm mentioning time, before I tell you what the bug is, I have to always recommend Shipylev's excellent writing about time, and there is a lot of complexity with dealing with time in computers. The article is from 2014, but it's an awesome read. If you're curious people, like you are, because you're here, I do recommend reading that. It's not a very sleep-inducing article. I found it extremely exciting, because there are things out there. So, time. What happens? When you do instant.now and print it, instead of getting 3 digits after the dot, you now get 6. And, yeah, what's the meaning of this? Well, Postgres, for example, stores timestamps with microsecond precision. Before, that would be truncated to just 3, which means all your tests would just work. And now things start to slightly go out of sync. And some code assumes 3 digits, some code assumes 6 digits. The code that has 3 digits gets expanded and doesn't really match the 6, which means you get a lot of strange exceptions or bugs or test failures in your application. This took us quite some time to fix. What we did, and what I usually recommend people do anyway, is if you're dealing with time, insert the time through a piece of code that you control. If you rely on instant.now and things like that, you don't have any control. Mocking becomes tricky or convoluted and hard. We do something like a time provider. A time provider is the entry point to how applications in Revolut get time. This has a similar API, but not the same as the java.time package. Why? So that an IDE will not get surprised and it will not give you suggestions of using the wrong methods and the wrong static methods. We use the types. We didn't do anything. It's just an entry point. If somebody needs to acquire time, they get it through the time provider. Time provider can say what precision is expected of a clock. For us, in most cases, millis is actually what we want because of all the provider integrations. Millis is what we get on the entry. Millis is what we also should provide on the outbound. And another bug that we discovered, not only us, of course, date-time formatter. When you were using date-time formatter with Locale UK, and given one of the offices is in the UK, and we have a lot of customers in the UK, we got a null pointer. Strange, but this happens. What you have to do is, instead of doing that with Locale of UK, you have to do Locale English. We replaced everything with Locale English because that's at least allows some consistency, because not using defaults in locales, that's a source of joy, as you probably know. Compiler bugs, there have been compiler bugs. Sadly, the easy one, sometimes some builds, I don't want to say at random, but it almost seemed like at random, would fail with a bug saying message file broken, so you don't even see what the problem is. If you explore the JDK bug database, you will see that that bug is a duplicate of something, which sadly has only been fixed in version 12. And in here at the bottom, you'll see that there is a list of bug ports, and it's not complete because it's growing. And this actually is highlighting why the support model and the support, well, release discussion is an important thing to keep in mind, because if there is a bug in JDK 11 and it's fixed in 12, 9 and 10 will not see this fix ever. 11 will see it because it's an LTS edition, but the fix is in 11.0.4, which is not publicly available. Well, it is publicly available, but to use it in production, you need to have a license, and so on and so on. So using a supported LTS goes a long way. Another funny bit, anonymous type class inference gives you a null pointer. Well, what does it mean? That if you try to do something like that, you'll get a null pointer. Our approach to the problem, don't use anonymous classes as frequently. It was a bit of a, well, we just did it and the bug went away. Actually the biggest problem that we had with Java-C and generics is Java-C has a problem with captures. The problem is still sadly unresolved. The problem manifests itself in a runtime problem. So compilation goes, sometimes goes okay, sometimes not. If you have a generic which extends something, what we had to do was replace it just with a question mark. That bug is still open, that bug is still happening. Sadly, one of the some of the results of this bug were runtime failures. So your compilation went fine, and then things exploded at runtime in production. Not what you want, so I have to mention it. What can you do if you actually care about the type? Other languages come to the rescue. I am a fan of Scala's type system because it allows to express a lot. If you want to capture those types, you can use Scala as a workaround and ask Scala code to give you hints and give you a lot of help. If you don't want to use Scala, well, if you can live with just a question mark, that's also an option. And then people who are performance-oriented will probably say, well, G1. There has been a lot of conversations about G1. In 11, the default GC is G1, and this G1 is very much, it's a different G1 than G1 that comes in JDK 8. Not the same thing, completely not the same thing. We are happy with this. What we get to see because of Ben, so I had to kind of poke at him because we use New Relic. We see garbage collection expressed as CPU time instead of pause time. And I would like to see the pause time because it's kind of important, kind of useful. Hopefully this will happen soon. I'll keep my fingers crossed for you. In JDK 11, full GCs with G1 are multi-threaded. Actually, since JDK 10. We don't have to do magic, almost any fiddling with GC tuning to have to achieve pauseless on a human perception level for our services. This is such an empowering life changer compared to JDK 8 that it's hard to describe. Our heaps and our application usage has kept growing month by month. And what we do is just change the container size, give it more memory, and that's it. And it still works reliably. We still don't have problems. We don't have crazy pauses. And it works well enough that we don't have to pay too much attention. With a caveat, we don't run Cassandra. We don't run too much latency-sensitive code. So this is, as I said, in context of what we do here. But basically, if you run web services or microservices that have to reply within a few hundred millis, from our point of view, we just kept increasing heap sizes, and there were no issues. Another nice feature is we had less problems that required GC logs, to the point in which, in most cases, we actually don't need them. I would still recommend you do take GC logs because they are useful when they are needed. And another nice feature of G1 in 11 that we have observed is if an application is to do an out-of-memory exception, you will see it faster, or we are seeing it much faster than what it used to be in 8. And in 8, there was, that behavior is still present, but there is a case in which you can get an out-of-memory exception, GC overhead limit exceeded. Is there anybody who has never seen a bug like this, or an exception like this? No hands in the room. The problem is, well, what happens here? GC will try to run, it will try to reclaim memory, and it will say, okay, I give up after it passes a certain threshold. The problem is by default, and I know a lot of people don't know of this flag, that this flag even exists. It's after GC spends, well, the application spends 98% time in GC. So 98% time in GC, all cores are burning, your machine is steaming hot full speed, and you're waiting for an exception to happen. Our exceptions come much faster in 11. We're happy. Caveat now to 11, we noticed that containers started dying at first. Well, I could do a demo here, but I won't tempt fate, and I won't tempt the internet. So imagine I have logged into Oracle Cloud because it's the most blessed environment that I can, and I'm comparing JDK 8 at the bottom with JDK 11 at the top. What you can probably see, or if not, don't worry, that RSS for a similar memory usage is slightly higher in 11. That's basically what we have observed across the board, that Java 11 requires slightly more memory from the operating system than 8, which means we just change the XMXs and the max and start heap size for containers so that everything fits into our precisely calculated container size. And, oh, it worked. Faster out of memories, I already mentioned. And Java 11 comes with new language features, which you already know very well. Some people on Twitter claim that var is an absolutely useless thing and they don't want to use it. Some people hate it. They are absolutely entitled to their opinion. What we have analyzed, well, I've analyzed one of our projects, and I see that at first people were a bit cautious with using var, but then the feature quickly caught on, and people actually like using that. People like replacing final something with vars because it's just less characters, it's just less reading, and usually the code that it replaces is quite obvious. So we've seen great adoption with this, and you might see a dip. The dip happens because we took a module out of the main code base. Also, you probably know that as of release 9, underscore is a keyword. You cannot use this as an identifier, but don't worry, people are creative. Well, this is what I just said. Again, but you can use double underscore. Double underscore is still legal. If you have used other languages, if you want to have underscore in Java, you can do double underscore. It works to the same effect. And there is another awesome thing that I think Ben can speak about even more. You even gave a talk on Monday at LGC. Java Flight Recorder and Mission Control are open source. That means that you don't need to get a license to use them. You can just download it, you can compile them yourself, and you can analyze your running JVM 11, JDK 11 application with those excellent tools. If you've never used it, I would recommend give them a try because it's going to change your life for the better. And with that, the logical question is, what do we plan to do next? One option is go Java 13. Java 13 has a lot of improvements in G1 space. Much better behavior from the garbage collector. For example, much more controlled pause times. If you were to graph, 11 can be all over the place, 13 can be following a trend, less memory hunger, so smaller RSS size compared to 11. However, it's not supported anymore because now it's going to be time for 14, which comes out very, very soon. So how about 14? 14 has an amazing feature for observability. Flight recorder event streaming, awesome, we want it, we would like to have it now even. However, Gradle does not work with Java 14. Gradle doesn't work with Java 14 because Groovy. What we are planning to do is wait them out, let them solve their issues. When it's available, we will go there because we don't need that feature. It's not a killer feature for us. We will probably get towards that stage, or we can hope for some very kind people to backport those features, hopefully, maybe, to maybe other GTKs, maybe. That would be awesome. Another thing, what we are going to try next is Graal, because especially with native image, it's a thing we want to test. I am aware that there are some changes to how GC works in native images, but we want to give it a try. And now the question is, how should you go about upgrading your apps to JDK 11 or later? Just try to compile them, try working with that. And before I say thanks for good, I am ready for some questions, because it's almost the time for questions if my maths is correct. This is the bottom line of the talk. I want you to upgrade Java if you're before 11. It's probably a good idea. It has worked for us very well, and many of you can have a good experience, even in a big organization. This will require, the whole process will require some planning, because it's the list of changes and the list required to the application is not just changing the underlying JDK in most cases. So it will require some work. It will require some planning and scheduling and working with, well, product owner or whoever organizes your work. But this should be done, and this will allow you, this will put you on the path to greater, newest features. Now we will have question time. The way questions work is raise your hands, and Alex will be super kind and walk up to you. And there is a question in the back already.
There's a question there as well. But before we do that, can we just say thanks to Ags for the excellent presentation?
Thank you for the talk. So you mentioned that one of the driving factors behind the migration was that you wanted to move faster.
Yes.
So you migrated. Are you moving faster now?
Yes, we are. How that exactly is happening? We can, for example, if we need to react to load increasing because our customer base is increasing, we just give containers more memory, and it just works. We don't have to do anything there. Also, another important thing is hiring and finding talented people who are inspired to do good stuff. Those people are probably already curious about 11, so they want to work with an organization that's already using new features. It's a very important thing because the talent in tech is very hard to find because there is a lot of competition. So yes. One question that you might have asked, the performance. We were happy about the performance, no problems there. As I said, it's a human perception latency that we are trying to optimize with most services, which means it's not millisecond or sub-millisecond latencies that we have. We're happy with having replies with, let's say, 10, 20, 30 in that range. There is a question. Awesome, I see you.
Hey there. You mentioned that you moved away from embedded Postgres to test containers.
Yes.
What's the reset time between tests for test containers?
I don't know the individual time for a reset. I could maybe try to check it, and we can talk about it later in the day. Out of the blue, I don't know. The whole test suite, and there is a lot of tests, takes almost an hour, but the number of test cases and tests is counted in tens of thousands. So it's an effort. It takes time, but we are at least happy, quite sure of our applications. I see you. Perfect.
Hi, thanks for the talk. Just wondering, with your Docker images, did you find any particular base image for Java 11 that you recommend?
We built our own. The way application is assembled, there is a base image that has Java runtime in it, and then we marry that image with a jar file that contains the application and all the other things that we have. So I would say look at what Adopt OpenJDK people are doing. That's probably a good source for inspiration at first. I cannot recommend anything in particular because we're baking our own.
Okay, I think we've got time for one last question.
Thank you. I was just wondering, I don't know how much independence the teams within your organization have, but how did you coordinate it across the firm? Did you kind of have one rollout for all the teams together, or were there some pioneering teams that drove it and the others followed?
So we did have to coordinate. So there is a bunch of applications that make Revolut do what Revolut does. We started with one application and then we moved on. When we were quite certain of the image that has been upgraded and that the outer layer of onion that I talked about already works, we started to switch individual applications. verify that they run correctly, because of course we have tested. We were quite sure that it's going to be fine, but as I mentioned with the generic bug, that was an unexpected one, and that still happened because, well, it's still out there. So we had to modify individual applications, but one by one, there was a blessing from the CTO, and that was required, but more details I think we can take offline, because I think we are running closely out of this. I wanted to show you one more thing. Which JDK, because you probably wanted to ask, we've obviously adopted OpenJDK. And I'll finish with this awesome show of my Photoshop skills.
Okay,
Thank you so much.
Thanks very much, Alex.